Perfect. Good morning, everyone. Uh, I thought to first complete yarn and then move on to scoop and hive, so that we can start our development part. As you know, we were talking a lot from last 1 month about MapReduce, about yarn, about the job tracker, task tracker, and how they manage the workload. I thought it's very important for us to understand the performance optimization part of it as well, which will very much help you in selling yourself when you attend an interview, because none of them in the real time has really got the knowledge of yarn performance tuning. What really makes a difference in tuning the yarn so that your all the workflows, all the application jobs which are MapReduce oriented and non-MapReduce oriented will run fast. Today my agenda is that one. This is completely theoretical, guys. Very basic core concepts. However, I'll ensure I am showing that in a practical thing by changing the configurations or by showing the configurations where they sit. Okay, so you can ask me doubts if I'm not clear, or if the way you understanding is a bit confused or something like that. Okay, let's start off. I was just cross-checking everything before I start the class, so it was okay. The first thing today, let me make it a big screen before that. Okay, today this is our agenda.
Amal, can you share the screen?
Oh, sorry, man, I didn't share the screen. Sorry for that. Yeah, can you see my screen now, everyone? Can you see my screen? Yep, perfect. Thanks. Now, today our concept is understanding the important conceptual and practical architecture of yarn and schedulers. Yarn is yet another resource negotiator. Provide a basic understanding of components that make up yarn. Okay, yarn is yet another resource negotiator, but there are several things that make up yarn to look like that and work like that and do like that. Okay, now illustrating how a MapReduce jobs fit into yarn model of computation. Now, you know MapReduce 1, you know MapReduce 2, you know yarn. Now, how exactly does a MapReduce jobs fit into yarn? MapReduce job is nothing but a mapper working with respect to a map task, intermediate phase, and then a reduce task. This complete process of a MapReduce is taken up by yarn, and how that job is fitting into this model is what we are talking about today. Although Apache Spark integrates with yarn as well, this series will focus on MapReduce specifically. Let me reiterate, Apache Spark is not a MapReduce job, it's a non-MapReduce job. You need to be very clear on that one. It is integrated with yarn in terms of resource management, workload management, and resource utilization. But Apache Spark is non-MapReduce. It is in-memory processing. Once we start discussing on Apache Spark, that things will be very clear for you. Okay, and we can for information about Spark and yarn, I'll explain you earlier. Okay, present an overview of how yarn scheduler work and provide a building block examples for scheduler configuration. We are going to understand how exactly a yarn scheduler works, and while learning how a yarn scheduler works, we are also making a building of block examples within the configurations of our Hortonworks cluster configuration. Now, this demo is broken into yarn basics. First one is cluster and yarn basics. Second one is global configuration basics. Third one is scheduler basics. Fourth one is fate scheduler queue basics. And fifth one is using fate scheduling queue properties. Part 1, Part 2, Part 3, Part 4, Part 5 is all about yarn, is all about schedulers, is all about queuing, is all about user weights and how you allocate resources to each of your user. That's all about our agenda today. Now, if you see this here, I have a diagram. The diagram very clearly explains your master is a resource manager, okay, which is the daemon communicating with your clients, track the resources on the cluster, and also manages the tasks that are given to the node manager. You have a master on your left side and you have a worker on the right side. Your master is your resource manager and your worker is your node manager. if you observe very carefully, each of your worker node manager has got a dedicated CPU, dedicated RAM. CPU is your processing engine and RAM is your in memory. Okay, the memory that is dedicated to it. Now, the way you need to understand is CPU depends from node to node. The number of virtual process you're assigning to a CPU or number of virtual process you're assigning to a node, which is a worker node, a data node. Okay. RAM will be, if you have RAM will, each individual machine will have a set of dedicated RAM, which is 32 GB, 16 GB, or minimum starts with 32 GB in production systems. That's how it works. Okay. That is a master. Master is a daemon that communicates with your clients, track resources. For example, job manager or resource manager on the name node or master communicates with the task tracker on the data node or node manager. Now, a node manager is a daemon that launches the task process spawned on worker host. Means a node manager is the one that launch the task process. I'm not sure if Vamsi is in the class today. Vamsi was asking me this yesterday. No, I think he hasn't learned the call today. That's okay. He was writing some exam yesterday, and this question was there. This question was there yesterday. Sorry. A node manager is a daemon that launches and process the worker host. Okay, means to be practical about this process, your resource manager is only responsible for assigning CPU and memory for your task. But who is going to launch and process that task? I mean, who is going to start that task? It is nothing but node manager. A very important question. Now, a yarn configuration file is an XML file containing properties that is used to configure resource manager, node manager, and by default, this file is in yarn site.xml. Let me just go back a bit. I have shown you this already, but I would like to show you once again. Where am I? Okay. Let me go here. You don't have yarn here, so I think it will be in different directory. Let me go ahead and check that. cd user lib yarn. You don't have, it's a worker node, so they might have put in a name node. So what we'll do is we'll check in this one rather than wasting time on that one. Okay, if you go to yarn, okay, yes, classes recording, so don't worry. If you go to yarn, if you click on config, okay, once you click on config, it's very slow, bear with me. You will have yarn site.
Go to advanced, Hammer.
1 minute, 1 minute, 1 minute. Am I not on advanced?
No.
Yeah. Now if you go here, yarn site dot. If you see here, you have yarn environment template. You have yarn log4j properties, and you have yarn set.xml. Okay, let me click on this, and these are the basic configurations that your yarn is built with. Okay, this one, if you do a VI editor, you will get more features to see how your resource manager is configured, how your node manager is configured, and how other individual components are communicating to each other. That is where your yarn site.xml is built to have inbuilt configurations to work with. Okay, so this slide is explaining you about your master node, your worker node, your resource manager, and how your each node manager has got dedicated virtual memory and CPU. Hope I'm clear on this slide. Let me go to the next slide. Now, yarn's virtual cores and memory. Yarn currently defines two resources. One is virtual cores and other one is memory. Each worker node or each node manager tracks its own local resources and communicates the resource configurations to resource manager. Once again, look at diagram. Look at the diagram. You have a worker node. In worker node, you have a dedicated CPU. You have a RAM. RAM is 128 GB and CPU is 8 by 8 virtual core process. And what happens to your worker node 1, worker node 2, worker node 3, worker node 4, worker node 100 is the amount of resources used by each task launched by the data node or worker node will be reported to the resource manager, which is on the master. I repeat that, very important statement. Each node manager tracks its own local resources and communicates its resource configurations to resource manager, which keeps a running total of cluster available resources. Now here is the point. You have 10 node cluster, you have 128 GB RAM, 128 GB RAM into 10 times, okay? 128 GB into 10 times is the total cluster memory. However, it keeps track of the effort utilization spent by the node itself along with the cluster available resources. Now, virtual cores has a special meaning in Yarn. You can think of it as simply usage share of a CPU. CPU is different, virtual CPU is different. Virtual CPU is nothing like your CPU releasing n number of threads for your process to finish the work faster. Okay, if I have only one thread for one, if I have only one thread for multiple, if I have one thread only one, I'm sorry, if I have only one thread for one process, which is quite troublesome, and if you have if you have one process releasing, if there are multiple process threads releasing for a one activity or one task, your process will become faster and your CPU threads will be efficiently utilized to finish your work faster. That's how you can take it. Okay, if you expect your task to be less CPU intensive, one more important point, whatever you work, however you work in Yarn, you always have to think about using less CPU, using less memory, using less network I/O, and using less disk I/O. Four important things: CPU, memory, disk, network. What changes can make you to go there so that your process will take less CPU, less memory, less disk I/O, and less network usage? Now, we are talking about, in this point, we are talking about input output incentives. You can see the ratio of virtual cores to physical cores higher than 1 to maximize your use of hardware resources. Okay, I'll give an assignment for you, every one of you. Try to understand the difference between virtual cores to physical cores and come back to me tomorrow. It's a just one line word. It's just one line word, but you need to understand what is the core difference when a task is launched on a physical CPU and when a task is launched on virtual CPU. Okay, that's what it is. Any questions on this slide and before slide? If you have any questions, feel free to stop. I can repeat that. Done. Now, containers of Yarn. I have been telling you, guys, every job in Hadoop is an application. Okay, your application to run will have an application master. Your application master will internally have a container. Your container internally will have a thread. That thread will be processed or made to run using a dedicated virtual CPU and RAM. That is the point where we came now. Look at the diagram first. You have a container. Your container within your data node. Okay, has got a virtual core request of 1 and your memory request of 8 GB. Means your application master, which is running multiple process, has a container request to handle that load, which needs 1 GB of, 1 virtual core and 8 GB of RAM. This is about your container. And if you see the right side diagram, you have a process running. That process has a code, and that requires disk usage, RAM usage, and CPU usage. Okay, that's what it will. Now let's talk about theory of it. Containers are an important yarn concept. Container is nothing but a request to hold resources on a yarn cluster. Currently a container is holding, I'm sorry, currently a container hold request consists of a virtual core and a memory. Okay, so once a hold has been granted on a host, the node manager launch a process called a task. Try to understand. Try to understand. If your container request has failed, the task cannot be launched. If the container request is processed, is available, only then the task will be launched. Once the task is launched, from that moment your resource manager and node manager starts communicating to each other and keeps a track of resource utilization and keeps the track of the status of the completion and all this stuff. Okay, the right side of the figure shows a task running a process inside a container. Okay, if anybody asks you what is a container, just tell them there will be a task running as a process inside a container. That container, first a request has to be placed for the resources. Once the request is processed, once the resources are available for your task to run, that is a container. What is a container? Basic common question. What is a container? You'll have something in it. It will contain something in it. In that way, your container in here is nothing but the resource of your task to complete. It has a task to do. It needs something to do the task. That is your virtual CPU, your RAM, and your disk. That is where you have to think about optimization of disk I/O, optimization of network I/O, optimization of virtual cores, optimization of memory. Clear, everyone? Hope the points are connecting the dots from point 1, point 2, point 3, point 4. Now, running process and application masters. So there is a slight difference between container and application master. Don't get confused. First I'll explain the diagram and then I'll move to theoretical. Okay. You have a client and you have an application process that launches by every client. Okay. Now, the first request goes to master, and master will have a will know what are the resources available. For example, your master has a virtual core of 60, a RAM of 90 GB, and at the moment the virtual core use is only 1 and RAM is used is 8 GB. This is the resource utilization or effort utilization of your master. Now go to your worker node. Your worker node has a node manager and it has got virtual core 60, memory 90, and virtual core uses 1 and RAM uses 8 GB. Within the worker node, you have a container request which is already running that has got virtual core request as 1 and memory as 8 GB. Okay. Now in this diagram, what you understand is, your master and your worker node will be continuously coordinating for your application master, which is running the task for you. Okay. I repeat that statement. Kindly understand. Container is the one which places a request for a task so that it can have the memory, CPU, and disk to complete. That is a container. Application master is an application process that is coordinating with your master and worker nodes with the available resources what they have, so that it can come to an idea what is required further to move. Okay. Now, an application is a yarn client program that is made up of one or more tasks. This one or more task will need to know what is the total resource available in the cluster, what is the total virtual CPUs, what is the total memory available in the cluster, what percentage of them are used on the each of the worker node, and where can I launch a container for my application master. That is the whole funda of it. Now, for each running application, a specific piece of code is called as an application master that helps coordinating tasks on Yarn cluster. The application master is the first process runs after the application starts. This statement itself makes up everything. The application master is the first process that runs after the application starts. What is an application? It's a job. What is a job? Your MapReduce code containing scoop integrated with Hive, your MapReduce code containing to load the data, insert the data, transform the data, or it can be anything. Okay, this task, once it started, the first process is called application master. This application master masters the resource utilization from the master node to worker node in coordinates with available resources and the used resources. Now, application starts and talks to resource manager for cluster, which I have told you very clearly. The resource manager make a single container request on behalf of an application. Now, this is a bit logical. Application is a job. A job is a task which has got multiple threads in it or multiple subtasks in it. One task will have a multiple subtask. One task is one job. For each job we have a container, and that container will be requested to a resource manager, and application manager will be knowing how much container do I have for my job to complete. The resource manager is that making a single container request for one task. If you have multiple tasks within your job, that multiple task will have multiple containers, and this multiple containers request will be placed by application master with a container request. Okay, on behalf of application means for your task to complete, there should be resources. That resource request will be made by your resource manager. Make sense, everyone? Any questions to till this point? Now your application master will be start running within that container. Means within that container, if the request you placed has got 1 GB of virtual CPU and 8 GB of RAM, your application should be running within that container, should not cross that container. For any reason, the request you have placed is given, but for some reasons that resource is not enough for you to process, your jobs will fail, your application will fail. Okay, the way you can share the memory is the next bit, which I'll cover little later in this slide only, but little later. Is it making sense to everyone? Are we in line with analyzing things what we discussed when we were talking about MapReduce 1, MapReduce 2 and Yarn? All these things came when we were discussing. I told them I'll cover all those things in a separate session. So if you are able to understand, let me know. If any questions, you can ask me now, so that will clear and move forward. Anybody, any questions? If one is clear on this process, how resources allocated, how a task is launched, where the task will be launched, how that works, and in your environment you will be able to tweak the performance configurations, enhancing the performance benchmark. Okay, that's fine. I think everybody's happy. Now have a look here, your application and your application master and its task. Okay, here I'll first explain a diagram and then I'll go into theory part. You have a client. Your client will be having an application running, which will first coordinate master, and from there you go to your worker nodes. Because you have a block, your block will be split into multiple data nodes, and you'll have to go and talk to each and every data node, and each and every data node should have dedicated containers which will help your process to run. In this one, the application master will request subsequent containers from the resource manager that are allocated to run the task for the application. Those tasks do most of the status communication with the application master. Okay, This resource manager and application manager and the task scheduling are like parent and child. They are for each other. They coordinate well, they work well, and they complete the task very well. Okay, you have to make the connectivity and behavior very clear. The application master will request the subsequent containers from resource manager that are allocated to run a task for the application. Your application is a job. Your job is a task. Your task will have multiple subtasks. For your multiple subtask or for your task, there should be a container requested. Okay, that container or subsequent containers from the resource manager will be requested for your each application. Okay, this application manager will do most of the communications from the resource manager to application manager. Okay, once tasks are finished, the application master will exit. Okay, exit means okay, I'm done now, I'm going to dead mode, I'm releasing all my memory, so whoever comes next will take over that application master containers resources. Okay, the last container is deallocated from the cluster. The point is, I'll give an example. I'm asking one of you to pick a task, and I'm giving you some memory, some CPU, and some disk IO for your process to complete. The moment you complete, you have to leave the resources there and you should get out of the cluster. Once you get out of the cluster, your resources, the container thread which you have used for your process to complete will be left vacant. So whoever comes next, whoever comes with their request from the resource manager for their container, for the application to work, will place a container request and this will be given to them. Okay. The application master launched in a container is more specifically called as managed application master. This is very important. What is the difference between managed application master and an unmanaged application master? Managed application master means it exits from the cluster the moment it finishes the work. Unmanaged application master means the one that runs outside of Yarn's control. Means though it has finished the work successfully, it will still keep the resources with itself, wherein Yarn has very loose control of the process. In the ideal realistic production environment, all the application masters are managed application masters only. There are no unmanaged application masters. You have to highlight when you explain the application master to everyone. I dealt in a situation where we have application master managed, but the configurations are managed as managed application masters, but they are working as unmanaged application masters where Yarn is not getting a control of it. We have made a few configuration changes within Yarn resource manager and node manager and restarted all the Yarn features wherein Yarn started working properly. It's a bug. Okay, so you have to highlight this type of things very clearly, which is realistic. Now, if you see the figure, you'll see an application, and within the application you have an application master, and in application master you'll have a task running multiple containers running on the cluster. Once again, your application master will have a container. Your application master should run within that container, and that container is in one of the data nodes or can be in multiple data nodes, because your data will be split across data nodes. So you have your application master and container should coordinate with those blocks to process your task. Okay, now MapReduce versus Yarn. There is a bit difference the way resource management works in MapReduce and the way it works in Yarn. One important thing. In MapReduce paradigm, an application consists of a map task and reduce task. This map task and reduce task are carried by a process called mapper. Okay, the number of threads it releases for your process to complete. Map task and reduce task align very clearly with Yarn. Okay, aligning is that they are compatible with Yarn. Now, let's go into point 2. In MapReduce application, there are multiple map tasks, each running in a container on a worker host somewhere in the cluster. The reason why they say somewhere in the cluster is it's not that easy for you to identify. The transformation is running on your data where the data is based. Okay, that's how it works. Now, similarly, there are multiple reduced tasks also, each running on the containers of the worker host. Container of the worker host means it's again on a data node. I repeat this silly, confusing line. In MapReduce application, there are multiple map tasks, which we all discussed, each running in a container on a worker host. Yes, that's true. Each map task will have its own a container requested by the application master to coordination of resources. Now, similarly, there are multiple reduced tasks, also each running in a container on a worker host. So you will have multiple map tasks, you'll have multiple reduced tasks. That's how the whole scenario is working. Now, simultaneously on a yarn side, the resource manager, the node manager, and application master work together to manage the cluster resources and ensure that task as well the corresponding application finish clearly. Okay, earlier it's all about your thread, your multiple mappers. In your multiple mappers, you have a map task, you have a reduce task. Your map task will be running on multiple hosts, and your reduce task is running on multiple hosts. That's how the whole MapReduce is working. When yarn came into picture, this complete map process or your map task, reduce task, and your multiple nodes based processing is tracked by your resource manager, your node manager, and its application master. Have a look at the diagram. If you see, you have one master and you have multiple workers. In your multiple in your worker, you have a node manager and you have a virtual core of 60 and RAM of 90 GB. At the moment, it's only one virtual core used and RAM is 8 GB used. In that, you have an container. Within that container, you have an application master. Okay, but in this, there is no map task. But if you go to other worker node, you have a container. In that container, you have a map task running. Okay, go to third worker node. There you have a reduced task running. Like that, your reduced task will run only when your map task is completed. Okay, but your application thread, your application process is still open and is exiting only after reduce is also completed and the results are flushed into disk. Okay, any confusions on this slide, anyone? I'm trying to be more easier way of getting things into your head, but if you think there is any confusions, let me know. Varun, Funny, Ram, Shailaja, any questions? This is very important. It seems to be fairly simple as I assumed in the initial phase, but this is the heart of your whole Hadoop cluster ecosystem performance, which includes Spark, which includes Scoop, which includes Flume, which includes Kafka, which includes Hive and everything. Somebody is asking a question. Let me check. Is master same as name node and worker named as data node? Yes. Master is your name node, worker is your data node. Don't get confused on that one. Your understanding is correct. I agree with you. Next, any other questions? Any other questions, anyone? Okay, no problem. Thanks for that. I hope things are very easy for you. 1 minute. Now, you understood yarn, you understood application master, you understood container, you understood how the application master internally manages the resources. Now you need to understand how ideally you allocate resources in cluster. Guys, before that, I wanted to ask you all a question. I wanted to tell you one basic thing. Out of total amount of memory that is in your operating system. You will dedicatedly reserve some memory for the operating system and dedicate all other to your tool. That tool can be Hadoop, that tool can be SQL Server, that tool can be Oracle, that tool can be anything. For example, if you have 16 GB of RAM available, in your 16 GB of RAM, at least 4 GB you will dedicate to your operating system, and the remaining will be dedicated to your tool. Hadoop is a tool, I can say, or the process that are running in Hadoop ecosystem. Okay. Now, in reality, there are two reasons why the full set of resource on a node cannot be allocated. The first reason is non-Apache Hadoop services are also required to be running on a node. Those non-Apache Hadoop service nothing but your operating system. Okay. Now, other Hadoop related components require dedicated resource and cannot be shared within yarn. For example, your Java heap size, your virtual CPU, your memory. Now, operating system overhead. Any node needs an operating system in order to work. We are using CentOS, somebody may be using Ubuntu, others may be using Fedora, and there are different flavors of operating system. But your Hadoop can run on any of the operating system. It is also applicable on Windows. Microsoft has started Hadoop flavors with Microsoft Azure and some insights. However, that is also working on operating system, right? When such kind of things are when there's a necessity of allocating resources to your operating system, running any operating system requires setting aside some resources. Most commonly for Hadoop, this is Linux. Most commonly, but still I have read several articles that Microsoft is also trying to come in pace with Linux for for Hadoop implementation. Now, other task is like if there is any custom programs that represent the worker nodes, you should set aside some resource for them. Okay, for example, your Cloudera manager. Guys, think practically, think very practically. You know, you are installing Cloudera as a distribution service on your Hadoop. Your Cloudera manager is completely managing your Scoop, Flume, Hive, Spark, HDFS, Yarn. If your Cloudera manager is down, okay, it doesn't mean your Hadoop is down. It just means it is not able to get the results for you on your Hadoop. For your Cloudera manager to get the reports for you, your Cloudera manager to coordinate things pretty well with your each Hadoop service, there should be dedicated resources for Cloudera manager to run. Okay. Now, SDFS cluster is required with a name node which is called master, worker node which is a data node. The master node daemon is called a name node and the worker node daemon is called a data node. Now, the Cloudera manager is Cloudera's cluster management tool for CDH. Cloudera manager is nothing but Cloudera's cluster management tool. The Cloudera manager agent is a program that runs on each worker node to track its health and handle other management tasks. Now, we have configured Hadoop cluster. Everybody did a great job. When you launched a Hadoop cluster, on the right side of your cluster, you have seen diagrams like HDFS IO, your cluster CPU usage, your cluster memory usage, your HDFS disk IO. Where are the reports coming from? Your Cloudera managed doing that work. How is your Cloudera managed doing that work? It has an inbuilt functionality. For its functionality to work, it requires resources. In terms of capacity planning, when you are doing a capacity planning, you should come to a conclusion. Okay, I have given a 32 GB RAM to configure a 5-node Hadoop cluster. In this 32 GB, I have to dedicatedly assign some memory to my operating system, some memory to my Cloudera manager, some memory to my non-Apache Hadoop components, which is like your cron jobs, which is cron jobs is also OS level. Don't get confused on that one. So apart from non-Apache Hadoop projects, you will still have to dedicate some resource to them. That's what it's trying to say. Now, for Hadoop installations, Cloudera recommends that HDFS data nodes and Yarn node managers run on same set of worker nodes in the cluster. I repeat that point. Cloudera recommends HDFS data nodes, and Yarn node managers running on the same set of worker nodes in the cluster. Worker nodes is nothing but data nodes. I told you very earlier, your resource manager and node manager, or your job tracker and task tracker. In MapReduce 1, it is job tracker on the name node, task tracker on the worker node. In Yarn, your resource manager, and then your worker resource manager, your resource manager on your master, and node manager on your slave. That is an important concept. Here what they say is your data node and your Yarn node manager must be sitting on the same set of worker nodes. Perfect. Data node requires basic amount of resources, setting aside proper operation. Good understanding. Now HBase requirements. If at all you are using HBase, you need to be extra cautious because HBase has a concept called region servers and master nodes. Your region server is nothing but your worker nodes. So for that one, the resource on each worker node should be set aside for region server. The amount of memory set aside can be fairly large. You should accommodate more resources, more memory for your HBase. If at all your project includes HBase planned. Now, Impala cluster requirements. If the cluster is configured to use Impala, resource on each worker node should be set aside for Impala daemons. The amount of memory set aside can be fairly large. You should be lucky enough if your project is not handling HBase and if your project is not handling Impala, because the way HBase works is, to be realistic, you have HBase masters, you have HBase region servers. The column value that works on HBase is utilizes more network, more CPU, more memory. If your capacity planning is involved with HBase, you must consider that into your plan. And if at all you're using Impala, which is nothing but a query executor on top of Hive, it has got Impala state store daemon and Impala master daemon. This also consumes more memory. So if it is also involved, then you have to take a different path, dedicating some resources for that one. Okay, Yarn node manager by default will give, which is not a big deal. Now node manager also needs some resources. Node manager is nothing but the daemon that runs on your data node for coordination of your Yarn jobs from the master to the worker node. Once the final properties are calculated, they can be entered in yarn set.xml or the Yarn configuration section of Cloudera Manager. Once these properties are propagated into cluster, you can verify them. Any change you made in yarn site.xml must be deployed. The client configurations must be deployed. Okay, only after the restart, the changes will take into effect. Okay, the very important concept. Look at the diagram. You have a name node, which is master. You have worker node, which is a data node. In the data node, you have a data node to a HDD, which is a disk, and like that, you have several other components within it. Now, verifying the Yarn configurations in the resource manager. Guys, let me open the lab now. Try to start thinking. Go to host. In the host, you have name node. You have two name nodes. You have what is the percentage age memory utilized in HBase and Impala. What is the percentage memory utilized by HBase and Impala? Mahinder, it depends. It depends. For example, if you have a 5 node cluster, the amount of memory you dedicate to HBase will differ. I'll show the calculator. I'll show the calculator right now. The way how we have to calculate. Good question, Mahinder. Thanks for coming on that one. Let me open that one. Hello, I'll show that right now. Good question. I appreciate that. I have the diagram here. I'll show you that. Come on, be fast. It's downloading from website. That's it is taking time. There's Excel sheet that explains everything. Let me open that Excel sheet. Okay. Now look at this diagram. Enable editing. Everyone, try to understand. Now that you have your base host configuration from step 1, use the table below to allocate resources, mainly CPU and memory, to various software components. Your operating system, you will be giving one virtual CPU and 4 to 8 GB of RAM. Your task overhead, which is non-Apache Hadoop components, you will give 0 virtual CPUs and you will give 8 GB of RAM. Your Cloudera manager, 1 virtual CPU and 1 GB of RAM. Other services, 0 and 0. Your HDFS data node, 1 virtual CPU and 1 GB RAM. Your Impala daemon, at the moment it is optional because you should at least allocate 16 GB memory when using Impala. Now your HBase region, it is 00 optional service, but if you decide to use HBase, then you'll have to allocate this memory. If you are involved in capacity planning in any of the project, this Excel sheet will be your heart, bread and butter, will be everything. This shows the maturity of your approach when you talk to your clients, explaining, now our cluster is planned like this. We are involving HBase. Now you have given me 32 GB RAM. I'll tell you something. If you give me 32 GB RAM, I will do my work right now. But in the long-term strategic planning, we end up doing firefighting because our project has involved HBase, our project has involved Impala, which are the most memory sucking features. So I want this to push back. Kindly give me some more memory so that I can dedicate something to Impala, I can dedicate something to HBase, so that I can make sure the project runs smoothly in a long-term strategic approach. Hope you all got where I'm coming from. Thanks Mahendra for asking this question. Your question has enlightened me to show this slide. I appreciate that. Hope your question is answered clearly. Everyone, come up with this kind of questions. I appreciate it. Now, if you calculate total, you'll have 44 here. You'll have 44 virtual core CPUs, and this one is around how much? 8, 8, 16, 24 GB. Now, if you see here, the physical cost to virtual cost multiplier will be 4, because see, this ratio is based on expected number of concurrent threads. This is the difference between your virtual CPU and physical CPU. Okay, this is the ratio on expected number of concurrent threads per core. Now, if you have 8 core processor, individually per core it has multiple threads which it can release. This multiple threads within one core, for example, one task, one thread is different, one task, multiple threads is different. So if you use virtual core, within that virtual core, every core will have concurrent threads released, which will enhance the performance of the process, how you execute and finish the work. Now, use one CPU for intensive task to 4 for standard input output. Okay, clear everyone? Guys, any questions on this one? For 10 node Hadoop cluster, this is the standard configurations. You have 56 GB RAM, you have 40 virtual cores. In that you have 8 CPUs, 6 cores, and this is the thing. Hard disk you have 36 TB because you have 12 into 3 TB. SATA third hard drive JBoard configurations. JBoard configurations, I'll tell you, what is JBoard. I'll tell you this later because this is something your operating system level. Ethernet 2, you are using 2 Ethernet, which is 1 giganet. This is basic core recommendations of Cloudera. Autonomous also recommends the same. I'll send this diagram, this Excel sheet to you everyone, so this will give you more knowledge, more things very clear. Okay, this is your YARN configuration. If you go YARN configuration here, This is your yarn configuration property. This is your resource memory. Okay, and verifying the yarn memory management will be like expected value for virtual cores, which is calculated from step 2 yarn available cores. If you go here, go to step 2, here you have step 2 here. Okay, this step 2, whatever you give here is that your node manager, whatever you give here with respect to this one, this will be dependent. Okay, so at the moment they are talking about expected value for visual cores total. Here they are expected value for memories total, means the number of task it is launching, number of memory, how much memory you are giving for each task. So it will calculate the total with the number of tasks. Verifying container settings for the cluster. Okay, this one I'll show you. I'll show the configuration right now. And this is all the features, how what you need to be very careful about. Okay, these are the sanity checks, very important stuff. Kindly please spend time on this one once you have free time. Okay, next go to MapReduce configuration. In MapReduce you'll have the properties dedicated, how much should be given to each one. This one is your this one I'll show you, I'll tell you each one very clearly. This one is explaining your application masters MapReduce CPU, which will cost how many. This one is talking about your application masters MapReduce memory. Okay, this one is your MapReduce map task virtual cores. This one is your map task memory usage. This one is Java heap size for your MapReduce process. This one is your MapReduce's reduce task virtual cores. This one is MapReduce reduce task memory usage. This one is MapReduce reduce task Java heap size. This one is your MapReduce input output sort split operations memory. Everything, every subtask or subprocess requires a memory, requires a configuration, and that configuration should have a value, and that value is what we are talking today. Okay, your MapReduce sanity check. If you see this sanity check, everything should be green. If something goes to amber or something goes to red, then you will face performance issues. Okay, if you see here, we are talking about application master sanity check, you're talking about map task sanity check, we are talking about reduce task sanity check. If you remember these things, if these things are on top of your head, your Hadoop administrator journey will be a cakewalk. You'll simply go and make a change on the configuration, you'll restart the yarn settings, and your cluster will be behaving pretty well. Okay, somebody's asking a question, let me check. Okay, no questions. I'll send this Excel sheet to everyone. Have a look when you have time, so it will be very easy for you as well. Now let me go back to the slide. Okay, now we are talking about verifying yarn configuration resource manager. So before going there, what I wanted to show you is, go here, go to dashboard, click on yarn. In yarn you have resource manager, click on the resource manager, or go to quick links. Once again, let me go back. I'm being unnecessarily speedy. Go to quick links, click on resource manager UI. Okay, in the resource manager UI, if you carefully observe, this is the memory used. Okay, this is the total memory. Okay, at the moment memory reserved is 0. You have total virtual cores is 18. At the moment you are using 15, so active nodes is 3, which is data nodes. Okay, now if you see here, number of apps running at the moment is 5, which is your jobs. Apps completed is this much from day 1. Containers running is 15. Now try to understand. You have 5 apps running, which is 5 jobs running. You have 3 active nodes, and you have 15 containers. Mean each application that is running is opened a container request on each of the active node. So 5 process, 5 into 3, 15. Okay, the 15 containers running at the moment. Now if you have 20 apps running, 20 into 3, 60. This is basic. This is minimum. This may go to 100 also based on the load you are giving on Hadoop cluster. Okay, are we making sense? Are we ensuring that our understanding of theoretical and understanding of practical are in sync? Everyone? Now, this is one area of it, and I've shown you this one. Now, assume, oh shit. Assume you have the following configurations on your 50 worker node. Now, yarn node manager resource memory. I'll show you where you can find this. Yarn node manager resource memory, right? Go to Ambari, go to yarn, go to configs. Go to advanced, click here. Yarn dot node. Amar, can you show up mapper class methods and reduce class methods? What do you mean? Your question is not clear, sir. Gopi, can you repeat your question? I didn't understand your question. What happens if you alter the block size of HBase column family on already occupied database? What happens if you alter the block size of a HBase column family on already occupied database? Well, here you're confusing people with HBase now. We'll talk about HBase when that comes. Don't worry about it. That one I'll cover. Second question I'm not clear. You need to repeat your second question. Can you show us mapper? Oh, you are asking me to show how you write a map method and reduce method. Is it? Is my understanding correct? Yeah. We'll cover that later, sir. That comes as a part of MapReduce development. Today we are working on the performance optimization of MapReduce. If you were on other class, I have shown you a MapReduce program which contains a map class, reduce class, and the configurations, the complete flow of MapReduce task. I'll show that once again. Don't worry about it. It's in my agenda. We'll cover one full length MapReduce task. Okay. Let's stick to our agenda today. That things we'll discuss little later. Leave it with me. I'm with you on that. Okay. Now if you see here, yarn dot node manager. Okay. Let me go to settings. See here, this guy is telling yarn node manager resource memory MB. This means in your yarn you have a node manager. For that node manager you need a resource. For that resource is nothing but it is split into memory, it is split into virtual CPU. Okay, how much is the memory you are giving? You are giving 9 GB. There it is written in MB. 9000 MB is fairly equal to 9 GB. Now for that yarn, in that yarn you have a node manager. In that node manager, how much virtual CPUs are you giving? Virtual cores are giving? You are giving 60. So that's where it is. This is the property. There they have given 9000. Okay, here we have given 80%. If you see here, the percentage of physical CPU allocated for all containers on the node, the amount of CPU for yarn containers only effective within the groups. This is your CPU. This is your memory. If you click on this one, the memory allocated for all yarn containers on the node. I just went to the yarn, I just clicked on search and this feature came. You can change it. Click on this one, edit, make change, restart. This is your CPU. If you see virtual cores, it is 6. Now the number of virtual cores that can be allocated for containers. This is used by the resource manager schedule when allocating resources for the containers. This is not used to limit the number of CPUs used by yarn container. It is set to -1 and yarn node manager resource dated hardware capabilities is true. This is little underlying concepts which he is explaining. We are not concerned about that one. Don't worry about it. Okay. Now this point is very clear to us. Now the way how this works is your memory is 50 GB. Okay, you have 50 node Hadoop cluster and you have 90 GB. So total memory is 4.5 TB. I have explained that very clearly in here. If you see my explanation on this one, where is that? Where is my resource manager? I explained very clearly here, and that guy is doing the same thing. Your total virtual cores and your total memory. Your total memory is nothing but number of nodes into your memory you have allocated for your yarn. If you see here, my total memory is 25 GB, okay, and my virtual cores will be 15, and I have 3 nodes. So 5 into 3 is 15, and 25 GB. Reason why I have 25 GB is I have 5 node Hadoop cluster with 5 things running, which is 5 into 5, 25. This may keeps changing, and if that changes, your memory used will not change, okay, but your memory total will be different. Your memory total will be like your operating system memory, your non-Hadoop components memory, your HBase memory, your cloud run management memory, and all the memories. But what is the memory used by yarn will be represented based on the these two things you make. Hope I'm clear on this slide. If anybody has any questions, stop me. Now you must be in a position to answer any questions if anybody asks you on the uh, yarn. Okay, now yarn uses 3 resource limits for allocating and enforcing those limits in the cluster. Now this is very simple, guys. Everything has got minimum and maximum. This minimum and maximum will be on virtual CPUs or VCORES and also memory. Now let me show you this one. Let me take this pen. Now if you see this one, this is about your minimum allocation. This is about your maximum allocation. This is about MB. MB means memory sizing. Now let's take about virtual core sizing, which is CPU. Very simple. Yarn scheduler minimum allocation. Yarn scheduler minimum allocation. Here they have given memory. Here they are talking about vCores. Here also yarn scheduler maximum allocation, which is vCores, means CPU. This is done. In this way, you're talking about memory sizing, you're talking about vCore sizing. Now let's nail down further your container allocation size increments. I told you what is a container and how that container inline works. We'll have a look. Now, yarn scheduler increment allocation MB within the container. Yarn scheduler increment allocation vCores for CPU, for memory. Now restrictions and recommendations for container values will be like this. Now memory properties. Minimum required value of 0 for yarn scheduler minimum allocation MB. Now we need to understand something. Where the hell is scheduler came from? Where the hell scheduler came from? If you are talking about your node manager level properties, it is yarn.nodemanager. If you're talking about containers, scheduler is the one that gets the container for you. That is the reason why the container memory configurations are entitled with the configurations that starts with yarn.scheduler. Okay. Now maximum value must be greater than or equal to minimum value, which we know. Now, virtual CPU minimum required. Minimum value will be 0. However, the maximum value must be greater than or equal to minimum value. Any of the vCore sizing properties must be less than or equal to yarn.nodemanager resource source vCores. Try to understand thing here. I repeat that. Any of the virtual core sizing properties must be less than or equal to yarn node manager dot resource dot vCores. This is because yarn dot node manager resource vCores is the total memory utilized for your yarn. So whichever subcomponent using a minimum value must always be less than or equal to the yarn node manager's configuration, but not more than that one. That is what it's trying to explain you. Okay, hope I'm clear. Any questions on this part? This is very important. Seems to be simple but little confusing. Hope I made it very clear. Be very careful. One time I made a mistake. I thought I was making changes to memory and I made it to virtual core. It was I'm changing the I was changing the memory from 16 GB to 22 GB for HBase. That was in my mind. I have to change that, but in a hurry I made it to VCORES. The VCORE was 1 at that moment, but instead of making changes to MB, I made it to VCORE. That VCORE was changed from 1 virtual core to 24 virtual core, and that after resetting and making the changes and restarting the yarn, everything started using by yarn and all the jobs failed, which led to a P1. I'm being honest. I gave them an explanation. I gave an uh, a sequence of events. I told them this is where it happened. This is by mistake happened thing, which will cover, which will not be repeated. So I want every one of you to be a little careful. Okay. The only point you must focus is, are they talking about minimum or maximum? Are they talking about VCORES or MB? And are they talking about schedulers, or are they talking about the yarn node manager stuff? Okay. Everyone happy? Any questions? Okay. Now MapReduce configuration. If you see this one in yarn, it's possible to do some very easy misconfigurations. If the container memory request minimum is larger than the memory available per node, then it would be impossible for yarn to fulfill the request. Obvious. Your container within your worker node, you may have n number of containers, which is fine, but your container memory request minimum, if it is larger than the available memory, it will fail, because your container minimum should always be less than the total memory available for your worker node. Now the map task memory property, which is, if you want I can show this one also, mapreduce.map.memory. Go here, go to MapReduce. Click on MapReduce.map. Okay. Now the MapReduce framework, if you click on this one, why is it not coming up? Yeah, if you see here, values similar to 2 GB are not recommended. It should be little more or less than that one. This is your MapReduce framework memory. That's what where we are talking about. Okay. The MapReduce.map.memory. This one is telling me that your map task memory only, not reduce task. The map task memory properties MapReduce.map.memory.mb. The reduce task memory properties MapReduce.reduce.memory. Since both type of task must fit in within the container, the value should be less than the container's maximum size. Okay. If you have given 1 GB to the container, in that 1 GB container, your map task to be 512 MB and the reduce task to be 512 MB, but it shouldn't be more than 1 GB. Okay. Special case will be your application master memory configuration. Your application master memory configurations can be tackled with yarn.app.mapreduce.am.resource.mb, means yarn applications MapReduce, which has an application master within it, and we are talking about resource of that one. This is used to set memory size of the application master. Since the application master must fit within the container, the property should be less than the container maximum. Hope you all agree to that point. Somebody is asking it out. Let me check that. Resource manager. What is resource manager? Funny, I didn't get you. What is resource manager? Oh, okay, no problem. Thanks. Yes. Okay. Scheduling yarn. Now, the resource manager tracks the resource on a cluster and assigns them to applications that need them. We were discussing it from day one. Scheduler is that part of resource manager that does this matching, honoring the organizational policies on sharing resources. Please note that yarn uses queues to share resources among multiple tenants. Multi-tenant means you have multiple components installed on your Hadoop cluster, which it can be open source. For example, if you take Hortonworks, within Hortonworks, if you have an application developer, he can develop one application and you can integrate that application within your Hadoop cluster. Okay, any third party which is open source, you can install that. You can ask your Ambari to pick that up and load binaries libraries and integrate as part of your Hadoop cluster. That multi-tenant, which can be reused for multiple components or multiple services, that kind of things. If you are having a cluster which is multi-subnet or multi-tenant cluster, then you need to be using queues to share resources. The way you use queues is HDFS, your share is this much. Yarn, your share is this much. Spark, your share is this much. Scoop, your share is this much. And the third party open source application which I just installed, your share is this much. That's how it works. The application master tracks each task resource requirement and coordinates the container request. Container request, I'm telling you once again, your application master which plays the request for container memory should be in line with the things we discussed in terms of application manager resources in MB. Okay, this approach follows the better scaling since the resource manager and scheduler does not need to track all containers running on the cluster. I repeat this point, very important. The application master tracks each task resource requirements and coordinates the container request. So the container itself can handle everything based on the request it is placing. Now, this approach is allowing the better scaling of the resource manager scheduler, which does not need to track the resource running on the cluster, because your container itself has come to an idea. How much do I need? How much can I get? Once I get what I need, I'll finish the work and close that container. So that application master will exit, which can be used by somebody else. Let me go back. Now, phase schedulers and queues, very important. I have promised you I'll discuss that later, and this is the where it is. Phase scheduler is a very popular choice, which is recommended by Cloudera distribution of Hadoop among the schedulers Yarn supports. In the simplest form, it shares resources fairly among all jobs running on cluster. Phase scheduler is fairness, means you have a job, you have a multiple jobs, and your resources will be fairly distributed among all your jobs. And introducing queues is nothing, guys. Your marketing team will have some queues, they'll have a weight. Your sales will have a queue, they'll have a weight. Your admin will have a queue, they'll have a weight. Your data science will have a queue, they'll have a weight. Okay, I'll show you that. This queue is also nothing but the way you are giving it to run. For example, this is your marketing. Where is my pen? Pen, please. Okay, this is your marketing. The weight of marketing is 30. This is your sales weight is 20. This is your data science, which sales weight is 40. You have admin, which weight is 10. So 30%, 20%, 40%, 10%. So if we have 100 GB RAM, 30 GB will be used here, 20 will be here, 40 will be here, 10 GB will be here. Now, what you need to understand is, whatever jobs your admin runs, they only have 10 GB of RAM. Your application master and your containers that are launched by this admin must be using that 10 GB only if queuing is enabled. Okay, if we have 10 containers requested by application master, for example, that 10 containers should be able to work properly with the 10 GB of memory you allocated to it. If at all 10 GB is not sufficient enough, it will wait for other application master's container to finish, so that will be released. It can take it and start working. Now, take marketing. Your marketing has got weight of 30%, which is 30 GB. So number of tasks you launch in marketing queue will be in line with the container request made by application master. Okay, hope it is making sense. Let me clear up the diagram. Let me go back. Now, queues are organizing structure of Yarn schedulers. I told you this earlier also. Allowing multiple tenants to share the cluster. Very good. As applications are submitted to Yarn, they are assigned to a queue by a scheduler. Very good. We know that. Your application is nothing but your job. Okay. As applications are submitted to job or Yarn, they are assigned to a queue by scheduler. The root queue is parent of all queues. Yes. If jobs are submitted as a root, he has all the authorization to use memory that is necessary for him. All the queues are child of root queue and other queue, which is hierarchical. Figure 1 represents the basic phase scheduling example of a phase scheduler.xml, a graphical representation of each queue share of the cluster. There are 4 departmental queues: marketing, sales, data science, and admin. There is a special admin queue that are used for Fred or Greg, who are assumed to be as administrators. One thing you need to understand here. Okay, in admin, I have a special admin queue for Fred and for Greg. They are they are they are they are part of admins. Only these two guys can submit jobs. ACL submit apps. Only two guys can submit apps. Okay, and this is a special admin queue. Where is the, let me, somebody's asking a question. Where is the phase scheduler .xml sits? It sits in yarn. It sits in yarn. If you go to conf, if you go to yarn configurations, in yarn configuration you will find all the capacity, all the schedulers.xmls. Okay, that's what it is. So this slide is done. If you have any questions on this slide, let me know. This is about phase scheduling and queuing concepts. Now, queue naming, weights, and scheduling. Now guys, this is very important. One level of queue allows sharing the cluster along one dimension, one queue per term. But it is common to share cluster among multiple dimensions per team and priority. Okay, one queue per team means, in earlier slide, your marketing has one queue, your sales has one queue, your admin has one queue. That's a different. Now, one queue can be shared across multiple teams based on the priority. That is where your resource pulling from one share to other share comes into picture. Phase schedulers allows nesting queues to form a hierarchical queue structure where each level should correspond to a dimension under its parent queue. For example, go look at figure 2. This figure 2 explains you that uh, resources shared along team and priority dimensions. The first level corresponds to the team data science. Okay, let's understand that one. Let me explain you little different way. Okay, now your data science is this one, this blue color, and in this data science, root is the main. In that root you have data science. Okay, for example, if in this case this is the first level which have the high priority. Okay, in this you can also have low priority. For example, if you see here, marketing 3 and reports 40, website 20, sales 4, North America 30, Europe 30, data science 13, short jobs 100. Okay, your configuration started here, it ended here. Okay, and my queue, wait, my queue started here and ended here. Okay, in that way, each and everything, let me clear this off. I'll show once again. Best effort jobs, short jobs, and for data science within the root user. Okay, within the share of data science you have a child queues that is called short jobs and best effort jobs. You are giving 100% resources to your short jobs and you are giving 0% resource to your best effort jobs. Okay, this is how the configurations you can change, you can tweak based on your requirement, based on understanding the resourcing in your cluster. Okay, example 1, we are talking about single queue. In that way, what I can say is, in sales queue, let's talk about this one. In sales, wait, let me take the pen. In sales queue, where is sales in here? This one. Okay, you have wait for. Now try to understand something. In sales you have two child queues, in this one, which is Europe, okay, which is North America. In this one, each has weight of 30 because total total weight you have given is 4. In that you have here 30 GB to North America and 30 GB to Europe, which is nothing but sales is your parent share, North America and Europe are your child shares. Now if you understand, if you come to an idea how much memory is needed for your main task to run, and within that main task there are subtasks, in within your main job there are sub jobs running. For that sub jobs to have enough memory, you can assign the whole memory to parent job, or you can assign some to parent job and some to child jobs, creating a hierarchy, creating a queue naming and waiting and scheduling for each of the independent components. Okay, now let's talk about market queue. In market queue, where is marketing? Reports, website, Europe, sales. What? 1 minute, somebody is asking a doubt, let me clear that. What is the significance of allocating zero weight for best effort jobs? This means best effort job won't run at all. That is he's just explaining how you can make the configurations. Where is the configuration setting? How you can define the parent hierarchy, parent and child hierarchy for your queue names. He's just giving a dummy example. He doesn't mean giving zero for it. Okay, don't take it. Don't take it that this is ideal. It's not ideal. They're just giving you the XML configuration how you can make it. Okay. Now I'm the pointer. Marketing queue. I think it's the next slide. Phase scheduling. This is okay. 1 minute. Where am I? Okay, this one. This done. We have done. We understood what is. We understood how you can give per team priority and per queue per team. Earlier slide. If you see this slide, it is per queue queues per team. If you see this one, queues per team and priority also within it. Okay, priority also, how much priority you give for North America, how much priority you give for Europe within sales. Website also, how much you marketing is here. 1 minute, let me, marketing is here. Within marketing you have website and you have reports. Okay, now in marketing you have two child queues which of non-equal. Where is marketing? Let here marketing, you have total of 3. Okay, in that 3 it has 40 GB for reports, 20 GB for website. Okay, this means the job and reports queue are allocated twice as many memories resources as jobs in the website queue. Is it? Now when you compare your reports queue, okay, this one, when you compare this queuing and this queuing, one thing is very clear, that you have allocated twice as many resources as jobs in the website queue, because report pulling will be very high than the website management. If you come to that conclusion, within the queues you can create a sub queue for your reports giving high memory to it, which you can define in your uh, configurations.xml. Hope things are getting clear to everyone now. I'm happy for that. Let me go to next slide. Phase scheduler queue basics. This one is very simple. You have a queue property, you have a fair share. Within that fair share you have a share weight, and that is how you can determine it. An ideal example we'll discuss here. A fair share is simply an amount of yarn cluster resources. You'll have memory, you'll have visual codes that indicates how much fair share you can give to that one. Okay, now a yarn cluster size of 1000 GB and 200 cores, and QX with weight 0.25 means all of the queues will have a combined weight of 0.75 and your queue will have 0.25. Okay, that's how is a phase scheduling concept works. Very simple. Queue placement policy, very simple guys, very simple, but you need to understand the logic here. Okay, let me open that. Now forget about previous rule. Okay, now you have a new rule, you have a new placement policy, you have a new queues, and you have sub queues. Okay, does the app specify a queue? If it is specifying a queue, does the queue exist? If the queue is, 1 minute, let me drag this to side. This is covering my, okay. Now If the queue exit, your app can go and submit that to the queue. Okay, once this is done, create a new queue. Okay, this is one step. If you don't have a queue, if your application doesn't supply a queue, go here. Okay, you cannot run that. And if your queue already exists, you'll submit an app. If your queue doesn't exist, is this rule allowed to create new queues? If it is allowed to create a new queues, go and create a new queues. If it is not allowed to create queues, go to next rule. Okay, that's how each and every queue placement policy works. First thing, queuing is very important. The reason why queuing is important is you are nailing down very deep so that you can allocate resources very well for your process. Okay, that is done. Queue placement policy is also completed. Thank you. That's all I have for today. So queue placement policy is done. Phase scheduling concept is done. And the reason why I haven't covered capacity scheduler, first in first out scheduler are, they are fairly simple. They don't really confuse you much because queuing and sub-queuing per team and priority, one queue per team are bit logical in phase scheduler. That is the reason why I have started with this one. All other things will be fairly easy. Once again, I wanted to reconfirm it is not possible for me to cover the whole ocean of Hadoop operations. I try to ensure covering most of the important bits that are necessarily important for you to understand and logical way of thinking. That's what I've covered in. Hope you have enjoyed the session today. Any questions? I can spare time for 5 minutes. Go ahead and ask questions. Surprisingly, none of them have asked questions to Gopi. Are all the containers given the same resource or can there be a heterogeneous minus? Sir, you can never say that each container will request for the fixed resource. It may sometimes, for example, if you give 1 GB for each container, it has to work in 1 GB only. For example, if that 1 GB you gave is not sufficient, it will struggle to complete. And if you have this fair share scheduling enabled, and if your queue can share from resource from one share to other share, it will go and share resources once the other process is completed. Okay, so in a nutshell, the straight answer to your question is no, the same resources cannot be done. It can be heterogeneous. Next question. Mahendra, Varun, Sailaja, Rajni, any questions? If you have no questions, I will end the class.
Sorry, Amar, Varun here.
Varun, go ahead, tell me.
Yeah, Amar, you showed that Excel spreadsheet.
Yeah.
And that's for 10 node cluster, isn't it?
Yeah.
All the memory allocations.
Yeah.
Let's say, in our company we are introducing 6 node cluster or 5 node cluster. How do you calculate the memory?
Yeah, it's very simple. See, this guy has given you 10 cluster. Okay. This is for 10 node cluster. Take this calculation and make this figures as per 6. Divide everything by 10. You'll get a normal figure, and that figure you multiply to 6 times. Simple. Now, very simple.
Okay.
Very simple, Varun. See, this guy, he is using around 24 GB of RAM and 44 virtual cores for 10 GB. Okay. Now you can divide this by 10, so you'll get per machine and multiply that with 6. That's it. And also it is not so dummy. You'll have to consider all these things. If at all you are using Impala, that's a different approach. If you are using Impala and HBase both, that's a different approach. You'll have to allocate memory properly to them, and amount of resource allocation, the amount of load that is running on HBase. Keeping that into mind, you can change them. Clear?
Okay, yeah. So we have to calculate manually, like depending on what cluster we are setting up.
Yep.
All right. Okay, that's fine.
Happy everyone? Any other questions? Any other questions, anyone? Okay. In MapReduce task, which thread handles shuffling phase? Is it mapper or reducer? Sir, good question. Shuffling will be done at map face only. Okay guys, I appreciate your time. Thank you for joining me today. We shall catch up tomorrow, and tomorrow we'll start working on installing Scoop and Hive. Once that is done, we'll jump into our CCA 175 stuff. Okay. Thank you everyone. Have a great day. Cheers. Thank you.